Hello everyone. Good morning all of you. Now today again we are here for our next class. I hope you are fine. Now today we are starting our next topic, the types of energy. We are discussing this one, kinetic energy. We discussed already in the last class, that is work done and energy, and your different form of the energy we discussed in your last class. So now we are starting our types of the energy. Kinetic energy. Kinetic energy, beta, I told you there is a two method to solve this one, kinetic energy. Prove these kinetic energy, that is depend upon the motion of any object. Kinetic means your motion. When any body is moving, when any object is in motion, that is your kinetic energy. Okay, so here this one method I told you, by using your simple formula, that by using your equation of motion, then you can solve this one, your half m square kinetic energy. Now second method we are doing there, kinetic energy, how we can solve, by using your calculus method. Kinetic energy by using our calculus method. Okay, let we are taking here any object whose mass is m, we are taking initially moving with some velocity, that is v velocity. Then after some time, then its velocity becomes there v, and it displays from here to there, let it is the s displacement. Okay, so here we are writing there, let m is mass of an object moving from one position to another at s displacement from initial velocity u and final velocity becomes v. Okay, this one we are assuming this object is moving from here, then moving in this direction, then after some time finally its velocity becomes v, and initial velocity of this object is s, then within your s displacement. Okay, so how you can find their kinetic energy? The energy conserved due to the motion of any object, that is known as the kinetic energy. So here, for the, as we know, so for find out energy, then we will solve their work done, how much work is done by this object from here to there, यहाँ से यहाँ तक जाने के लिए इसने कितना वर्क किया है, that work will store in form of the energy only. Okay, so here we will find, as we know, small work done by this object with small displacement ds we are taking. ओके, कि यहाँ से यहाँ तक इसने जाने के लिए कितना वर्क किया, वो वर्क अगर हम फाइंड कर देंगे, दैट वर्क विल बी स्टोर्ड इन फॉर्म ऑफ द काइनेटिक एनर्जी. तो हम अज्यूम करके चल रहे हैं, तो यहाँ से यहाँ तक स्मॉल डिस्प्लेसमेंट इसने कवर किया है, दैट इज योर ds डिस्प्लेसमेंट. सो ds डिस्प्लेसमेंट, स्मॉल वर्क डन विल बी देयर, देन if small displacement will be there. So here we can write there dw is equal to your f ds. Okay, in vector form, then we can write their dot, then here will be vector quantity. Here force and displacement both are acting in same direction. Force is acting in this direction, displacement acting there. So here we can write there f ds cos theta, then here theta is 0 because both are acting in same direction. So here we can write there f ds, because your cos 0 will be equal to your 1 only. So displacement small work done will be left there f ds. So how we can find, if its initial velocity is u, then final is v, then we can write there by using Newton's second law. By using Newton's second law, then we can write here dw is equal to here, by Newton's second law, F we can write there ma, that is ds. Newton second law क्या कहता है, force equal to mass into acceleration. Okay, so acceleration by using this one, as we know, in differential form, acceleration, instantaneous acceleration for any at instant body is moving during the motion. So for the any instant a, we can write there dv by dt. Okay, change in velocity per unit time, that is here acceleration only. So here putting value of a in this equation, then dw we can write there m dv by dt, then here will be your ds only. Understood? So here need of beta kinetic energy is equal to your half mv square. First we should know about this one, what you want to find out. हमें क्या find करना है, how we can convert this one in this form. Clear? So here need of the velocity, that's why we have to remove this one displacement and time, then only we will be there. Okay, so here we can remove this ds by dt, we can write there ds by dt equal to your velocity. Instantaneous velocity equal to change in small displacement to the change in time, that is v equal to ds by dt, we can write there. So here your left your mv dv. Now for the total, this one your small work done. For total work done, taking integration, take integration. For total work done, take integration from u to v. ओके, इनिशियल वेलोसिटी क्या आपकी v u एंड फाइनल वेलोसिटी बिकम्स हियर v. तो यहाँ जब वेलोसिटी इनिशियल u है बॉडी की, यहाँ तक फाइनल वेलोसिटी v हो रही है, तो यहाँ से यहाँ तक का हमें क्या निकालना है, टोटल वर्क डन निकालना है. सो वी आर टेकिंग देयर इंटीग्रेशन, देन put their limit after the integration, then take integration. Initially body is at rest. I told you beta initially जब mass क्या है, rest में है या moving some velocity u only, then work done will be equal to your 0 only. ओके, जिसके रिस्पेक्ट में आप डिफरेंशिएशन इंटीग्रेशन करते हैं, देन वी विल पुट द लिमिट ऑफ दैट क्वांटिटी ओनली. ओके, आफ्टर सम टाइम इट्स वेलोसिटी बिकम्स हियर v only of that body, then work done becomes total w by this object. So here we can write there initially when work done will be 0, here downside we will write there lower limit initial value, upper side we will write there final value. So here integration with respect to work done, that's why here we will put the limit of work done only. Initially 0 work done when velocity of this object is u only. After some time velocity becomes here u v, then work done will be w. Now here we can write there work done equal to your w only after the taking integration of dw, then w, then limit we will write there as it is, then here m we can take outside, so inside left here v dv. Clear? So how we can take integration of this one, after the put limit of work done will be there m as it is, taking integration here left here v dv. This one left na, initial value v and final value is v only. Okay, so put the limit of this one m as it is, then here integration of this one, how we can take their square of this one we will add in this power, then same we will write downside of this one power, then here final value, initial value to final value, then m v square final 2 we can take outside, final value of the velocity v, initial value of the velocity v we are taking. So work done will be equal to this one, but here need of the kinetic energy half mv square, that's why here we are applying their condition. A body is initially at rest, a body is initially at rest, that means here we can write there u equal to 0. Okay, what is the meaning of this one? Initially at rest u equal to 0, initial velocity is 0. So here work done we can write there m by 2, then v square by equal to your 0 only, then work done will be left here half mv square. So this work done will store in form of the kinetic energy. Work done store in form of kinetic energy due to motion of any object. So this one our calculus method to solve the kinetic energy, how we can solve their instantaneous velocity and using their instantaneous acceleration. Now see our next one. See this one question beta, how we can solve this one using your kinetic energy. A body of mass is 4 kg initially at rest. एक बॉडी है जिसका मास क्या गिवन आपको 4 kg गिवन है. We are writing there which one values are given, then write there first, then check which formula you can apply for find out this one. Okay, then initially is at rest. Initially rest means you can say their initial velocity of body is equal to 0 only. Okay, is subjected to a force of the 60 newton. Let we are taking their body and initially is at rest, then you can say equal to 0. After that 16 newton force is applied on this one, then what is kinetic energy acquired by this body at the end of the 10 second. जब इसके ऊपर क्या है फोर्स अप्लाई किया जा रहा, हाउ मच फोर्स 16 न्यूटन फोर्स वी आर अप्लाइंग देयर. तो कह रहा है कि कितनी काइनेटिक एनर्जी हो जाएगी आफ्टर दी 10 सेकेंड की यहाँ से यहाँ तक अगर ये बॉडी पहुंच रही है विद इन 10 सेकेंड, व्हाट इज काइनेटिक एनर्जी ऑन दिस पोजिशन एज इट विल रीच हेयर. क्लियर. तो काइनेटिक एनर्जी आपको फाइंड करनी, तो काइनेटिक एनर्जी में पता क्या होती है, काइनेटिक एनर्जी इज इक्वल टू हाफ mv स्क्वायर मास इनटू योर फाइनल वेलोसिटी. इनिशियल इज 0 ओनली, देन u इक्वल टू 0. ओके, फाइनल वेलोसिटी इज नॉट गिवन, दैट वी हैव टू फाइंड आउट कि फाइनली क्या हो जाती है 10 सेकंड के बाद उसकी वेलोसिटी. अगर आफ्टर 10 सेकंड वी कैन फाइंड देयर वेलोसिटी ऑफ दैट ऑब्जेक्ट, देन इजीली वी कैन फाइंड देयर काइनेटिक एनर्जी. ओके, सो लेट्स सी हाउ यू कैन फाइंड दिस वन. योर फोर्स इज गिवन योर बेटा 16 न्यूटन. What is kinetic energy required by this body at the end of the 10 second? Your time is given here 10 second. Clear? So from here we have to find out kinetic energy. Kinetic energy we know about this one, that is half mv square. ये आपको क्या करना फाइंड करना. तो इसके लिए क्या गिवन है, मास तो गिवन ऑलरेडी क्वेश्चन के अंदर, फाइनल वेलोसिटी हमें फाइंड करनी है. F given, initial velocity given, time given. Then if you can write there by using your force and mass, then we can find their acceleration or not. First by using Newton's second law. What is second law Newton? Force equal to rate of change of momentum. Okay, if mass will be constant, then we can write there F equal to ma. So force is given your 16 newton, m is given your 4 kg. So acceleration from here will be come out 16 by 4, that it will be your 4 meter per second square. This one our acceleration. After that your a will be there, t is there, initial velocity is there. Then can we find their final velocity by using first equation of motion, because s is not given. First equation of motion, okay, because your s is not given, that's why we can't use second and third equation. Yes na, if you can't understood beta, then you can write their all equation of the motion. V equal to u plus at, s equal to ut plus half at square. Third equation v square minus u square equal to 2as. These three equation we can use there. Okay, now see आपको क्वेश्चन में क्या निकालना है, फाइनल वेलोसिटी फाइंड करनी है. अब फाइनल वेलोसिटी फाइंड करने के लिए दिस वन इक्वेशन वी कांट यूज, दिस वन इक्वेशन वी कैन यूज, बट हियर बेटा नीड ऑफ s, बट इन our question given t, that's why here we have to find out, that's why we can't use this one beta in this equation. Two are unknown terms. a हम find कर चुके हैं, t already given है, s given नहीं है, तो इसलिए हम क्या यूज करेंगे first equation of the motion, v equal to u plus at. So here v equal to u plus at for find out final value. Initially body is at rest, that's why u will be equal to 0. Acceleration equal to your c, a is equal to 4 meter per second and t is equal to 10 second. That is your 4 meter per second square and t is equal to your 10 second. So final velocity will be come out here 40 meter per second. Always write SI unit of each quantity. So after that we have to find out kinetic energy only, half m square. Mass is given your 4 kg. Using this one, then we can write there. Hence kinetic energy is equal to your half mv square, that is half mass of this body. Here 4 given in our and final velocity is equal to your 40, then solve this one, then it will give us 80 meter, not your joule na, this one it will give us 80 meter. I hope you understood how you can find kindly as given their velocity, time and acceleration. Okay. Now see our next one topic. Now relation between kinetic energy and your momentum. Kinetic energy and momentum, then we discussed their linear momentum in last minute. Then linear momentum is laws of motion we discussed beta. When any body is moving with some velocity having some mass, then linear momentum we can say mv. As we know, linear momentum of body P. P is our linear momentum, that is product of mass and air velocity. If any object whose mass we are taking m moving with some velocity u and v, then you can write their momentum, we can write their mv. Okay, product of mass and velocity, that is linear momentum. Here we have to find out kinetic energy. Okay, kinetic energy here, that is your half mv square. Okay, now kinetic energy of that object if moving with some velocity, so kinetic energy we can write there half mv square. So here need the relation between kinetic energy and momentum. How we can find? We have to convert beta this one relation, that we can put value of their linear momentum. So how we can change this one? As we are multiplying and divide this one from both side up and down with your mass, then we can change into linear momentum. See how we can write there: multiplying and divide by m. Okay, this one first equation. Now see second equation: multiply and divide by m. इक्वेशन सेकंड को हम m से मल्टीप्लाई और डिवाइड करें, then nothing change will be there. So kinetic energy we can write there 1/2 mv square mass by mass. So this one m we can write there square 1/2 m square v square by your m only. So see here, this one mv came out, this one we can write their momentum, and here square of this one mass, square of this one velocity, then here we can write this one square of your linear momentum. So write this one formula, then kinetic energy we can write there p square by your 2m. That is important relation beta. This one relation is the between your kinetic energy and the linear momentum. So here square, you can write this one relation like this also. Then here p square equal to your 2m kinetic energy. Okay, then square this one, take this side, then here 2m kinetic energy. This one relation between momentum energy relation. Okay, this one our important relation, one only between your kinetic momentum. Okay. Now next see next question: the momentum of the body of mass 5 kg is your 50 kg meter per second, then find its kinetic energy. अगर क्वेश्चन के अंदर क्या गिवन है, काइनेटिक एनर्जी में पता है क्या होती है, हाफ एम वी स्क्वायर होती है, बट इन दिस क्वेश्चन गिवन आवर मोमेंटम. सो हियर वी विल यूज द रिलेशन ऑफ काइनेटिक एंड मोमेंटम, नॉट ऑफ योर हाफ एम वी स्क्वायर. अब आपको पता है काइनेटिक एनर्जी क्या होती है, हाफ एम वी स्क्वायर. Can we use this one relation? Because here velocity is not given. Okay, first write the given terms which are given in our question. Mass equal to your 5 kg and your p kg. If you can't find beta which one quantity is given, then you can identify with help of the unit, because kg is the mass unit, meter per second is the velocity. So this is a multiple of mass and velocity. Mass and velocity you can write there momentum. So p equal to your 500 kg meter per second. This one our momentum. So mass 5 kg, momentum is this one. So we can write their relation between them. As we know, we have done a relation between P and kinetic energy. P is your linear momentum and kinetic energy. Now already we have done. P is equal to काइनेटिक एनर्जी आपको फाइंड करनी, सो काइनेटिक एनर्जी वी कैन राइट देयर P स्क्वायर बाई आवर 2m. So use this one. Then kinetic energy is equal to square of P, 500 given, then square of this 500 divide by your 2 and m is equal to your 5. So here we can write there 10, sorry here will be 25 not 10, square of this one 25, then here will be a 10. Okay, so here left 2500, this one our energy is come out, this one here joule only. Write always SI term beta, which one quantity you are finding, then write always SI units of that quantity. Now see next question. A body of mass is 5 kg moving with the momentum of the 10 kg मीटर पर सेकेंड. अब आपको ये क्वेश्चन गिवन है, इस क्वेश्चन के अंदर कह रहा है कि एक बॉडी है जिसका मास क्या गिवन है 5 kg गिवन है. दैट्स व्हाई हियर फर्स्ट वी विल राइट देयर क्वांटिटीज व्हिच आर गिवन इन आवर क्वेश्चन. 5 kg is moving with the momentum of this one, let this one object is here, then moving with that momentum that is equal to your 5 kg meter per second. Means here we can say initial momentum is given 5 kg meter per second. Then a force on a 0.2 Newton is applied on this one. Here we can write there P1 initial momentum is given here 10 kg meter per second. उसके बाद कह रहा है कि फोर्स अप्लाई किया गया, कितना फोर्स अप्लाई करने कह रहा है 0.2 न्यूटन ऑन दिस वन ऑब्जेक्ट. ऑन इट इन डायरेक्शन ऑफ मोशन, डायरेक्शन जिस डायरेक्शन मूव कर इस डायरेक्शन में फोर्स अप्लाई किया गया है फॉर द 10 सेकेंड. यहाँ से यहाँ तक कितना टाइम लिया गया उसने 10 सेकेंड का टाइम कह रहा है. देन इट विल रीच हियर. क्लियर? सो योर टाइम इज गिवन इन आवर क्वेश्चन हियर 10 सेकेंड एंड योर फोर्स अप्लाइड ऑन दिस वन बॉडी दैट इज हियर 0.2 न्यूटन. सो हाउ मच इंक्रीज इन इट्स काइनेटिक एनर्जी, कि अगर इसकी इनिशियल वेलोसिटी क्या है u है, फाइनल वेलोसिटी ऑन दिस वन पॉइंट बिकम्स v, देन हाउ मच चेंज इन द एनर्जी. सो चेंज, हाउ वी कैन फाइंड दिस वन चेंज, change in kinetic energy, how we can write there change in kinetic energy, that means final kinetic energy minus initial kinetic energy, जितना डिफरेंस आएगा वो क्या आएगा, चेंज आएगा. here we can write there final kinetic energy माइनस इनिशियल काइनेटिक एनर्जी. इफ फाइनली इट्स वेलोसिटी, मास तो वेरी नहीं करेगा, किधर से किधर जा रहा, मास विल बी रिमेन सेम ओनली वेलोसिटी विल बी चेंज. इनिशियली इज u, आफ्टर सम टाइम बिकम्स हियर v, और कितने टाइम में 10 सेकेंड में. सो हियर वी कैन राइट देयर फाइनल वेलोसिटी m v स्क्वायर माइनस 1/2 m u स्क्वायर. अगर यहाँ पे क्या है, मास गिवन हमारे क्वेश्चन में 5 kg, हियर वी कैन राइट द वैल्यू ऑफ v एंड u, देन चेंज विल बी देयर. बट यहाँ पे क्या गिवन है, फाइनल वेलोसिटी इज नॉट गिवन इन आवर क्वेश्चन, इनिशियल वेलोसिटी आल्सो नॉट गिवन. सो वी हैव टू फाइंड दीज वेलोसिटीज, देन ओनली वी कैन ड्राइव दिस वन. सो हाउ वी कैन फाइंड, बेटा इनिशियल मोमेंटम इज given initial momentum 10 kg meter per second with respect to this one, then we can find their initial momentum p1 equal to mu, mass into initial velocity. Mass given in our question 5 kg, we will put value of 5, initial value we have to find out, and your initial momentum 10. So u we can write there, that is equal to 5, take this side, then 2 meter per second. This one come out our initial velocity. क्लियर? उसके बाद क्या नीड है, फाइनल वेलोसिटी. फाइनल वेलोसिटी कहाँ मिलेगी, जब ये बॉडी कहाँ पहुंचगी, इधर पहुंचगी. तो ये कहाँ पहुंची, जब हमने फोर्स अप्लाई किया इसके ऊपर 0.2 न्यूटन, तो 10 सेकंड के बाद कहाँ मिली, ये यहाँ मिली. तो इसके ऊपर क्या फाइंड करना, हमने फाइनल वेलोसिटी निकालनी है. तो इनिशियल वेलोसिटी हमारी आ गई. फाइनल वेलोसिटी के लिए हम क्या यूज करेंगे, v इक्वल टू u प्लस 80, because s is not given, that's why we can't use their second and third equation, but time आपको given है, that's why we are using their first equation only. So as we will use their first equation, then we can write there v equal to u plus 80. u आपको अभी फाइंड किया था, u क्वेश्चन के अंदर कितना आएगा, 2 मीटर पर सेकेंड. क्लियर? दिस वन यू सोल्ड नाउ 2 मीटर पर सेकेंड, बट इसके लिए क्या पड़ेगा बेटा, ए की भी नीड पड़ेगी, बट हियर ए इज नॉट हैविंग, दैट्स व्हाई ए फर्स्ट वी हैव टू फाइंड आउट ए। ए कैसे फाइंड कर सकते हैं, आपको फोर्स गिवन और मास गिवन है, बोथ टर्म्स आर गिवन, देन बाय न्यूटन सेकंड लॉ वी कैन फाइंड देयर एक्सेलरेशन और नॉट, सो फाइंड देयर एक्सेलरेशन बाय यूजिंग योर न्यूटन सेकंड लॉ। सो बाय यूजिंग Newton's second law, we can write there F equal to ma. ओके, तो ma को यूज करते हुए क्या हम फाइंड कर लेंगे, एक्सेलरेशन। फोर्स गिवन आपके क्वेश्चन में कितना गिवन है, फोर्स इज 0.2 न्यूटन एंड योर मास इज योर 5, सो यूजिंग दिस वन बेटा, force is 0.2, mass is your 5, then A will be come out 2 by 50. This only na? Then it will be your 25, 1 by 25 meter per second square. Acceleration is come out. Clear? So here we can find their initial final velocity. Put value of A in this equation. Put here, we can write this one equation, our first one equation, this one our second one equation. Okay, put value of A in equation 2. So second equation V equal to your U plus A2. आपका U क्या है, 2 मीटर पर सेकेंड, A आवर कम आउट योर 1 by 25 into टाइम, टाइम क्या गिवन था आपका, it is here 10 seconds, so use this one 10 seconds, then here we can write there 10. So after this one here we will show this one 5, then it will be 2 plus 2 by 5, then it will be a 2 plus 0.4, then it will be 2.4 meter per second. This one our come out final velocity. Understood? So use there this one final velocity, initial velocity our 2 only, फाइनल वेलोसिटी 2.4, तो यहाँ पे क्या आ जाएगा, हम इसको यूज करेंगे बेटा, फाइनल वेलोसिटी क्या है 2.4 आवर केम, इनिशियल वेलोसिटी 2, m इज गिवन योर 5 kg, देन फाइंड देयर चेंज इन द काइनेटिक एनर्जी। इस इक्वेशन में पुट करेंगे तो आपके पास क्या आ जाएगा, चेंज आ जाएगा। सो यूजिंग दिस वन, देन हियर वी कैन राइट देयर चेंज इन काइनेटिक एनर्जी चेंज 1/2, देन mass final velocity minus initial velocity, then 1/2, then mass is given in our question I think 5, mass 5 kg, okay 5, then 2.4 final velocity minus initial velocity our came 2, then solve this one, then here 5/2, then it will be 2.4 square, then minus 2 to ja 4. Clear? After solve this one, change in kinetic energy will become out. Beta, solve this one, then comment your answer of this question. Okay. Now our next topic, then work energy theorem. Okay. Next topic of this one, then we will discuss their work energy theorem. What is work energy theorem? This one theorem is explained total work done by an object is equal to change in the kinetic energy. कोई भी बॉडी क्या है, एक पोजीशन से दूसरे पोजीशन पे जा रही है, तो जितना वो काम करेगी वो काम किसके इक्वल होगा, चेंज इन काइनेटिक एनर्जी के। ओके, सो दिस वन वी विल फाइंड देयर हाउ मच वर्क इज डन बाय दिस ऑब्जेक्ट is equal to your change in kinetic energy. Let we are starting this one. Here object is here moving this one, let its mass we are taking there m only, initially moving with some velocity that is u velocity, then after some time again it will be final velocity becomes here v only of this object. So from here to there, बॉडी यहाँ से यहाँ तक मूव कर रही है, तो यहाँ से यहाँ तक मूव करने के लिए टोटल जितना वर्क रहेगा वो क्या रहेगा, टोटल काइनेटिक एनर्जी. सो अकॉर्डिंग टू दिस थ्योरम इट स्टेट दैट वर्क डन बाय द नेट फोर्स इज इक्वल टू चेंज इन द काइनेटिक एनर्जी. सो हियर वी कैन राइट देयर वर्क डन इक्वल टू चेंज इन काइनेटिक एनर्जी. फाइनल काइनेटिक एनर्जी minus initial kinetic energy. Final means when velocity becomes v, initially velocity becomes u. Now let an object of mass m moving initially with u velocity and finally its velocity becomes v. Okay, we will use beta same method as we have done there to find out the kinetic energy. Then here also we will use same method to find this one here, work energy theorem. How you can drive this one? That is equal to your work done equal to change in kinetic energy. हम यहाँ से यहाँ तक का क्या निकालेंगे, वर्क फाइंड करेंगे और वो वर्क किसके इक्वल आएगा, आपका चेंज इन काइनेटिक एनर्जी से. ओके, सो here we are taking there as work done will be small for small displacement ds. So here we can write there dw equal to f ds. For small work done, displacement also will be small. So for find out the total, then work done we can write there dw equal to your f ds. So by using your Newton's second law, then again we know about this one, f equal to ma, then we can write this one m a ds. So instantaneous velocity as body is going from here to there, then there's small change in the velocity within small time, then we can write there m equal to dv by dt. For at any instant, then acceleration will be change in the velocity. So here ds by dt, then we can write there mv dv. For total work done, then we will take integration on both sides for initial velocity u to final velocity v. So we are taking integration dw, then mv dv. Here also take integration. Initially velocity becomes v, then work done will be 0. जब body क्या है, यहाँ है, तो velocity क्या है u, work done क्या आपका 0 है. As it will reach here, velocity becomes v, then work done will be w only. So we are putting these limit here only. Final velocity of this object becomes v at your total work done w only. Now take integration of this one. How we can take this one, integration of their dw, w will be after the putting limit, then it will be w only. Then here will be mass as it is, then integration of v dv, initial velocity to the final velocity. So after this one, here we can write there m. This one we can write their integration of this one v square by 2. Here initial velocity to the final velocity. Now solve this one. Then here after the putting limit, then work done will be equal to 1 by 2, put limit, final velocity minus initial velocity. Final is v, then initial is u only. So here we can write there 1 by 2 m, open this bracket, then after this one we can write there half m v square minus half m u square. This one our work energy theorem. According to this theorem, total work done by any body moving from one to another position, then it will give us the change in the. I hope you understood beta this one topic of the kinetic energy. We discussed about the kinetic energy and work energy theorem. Then in next class we will discuss about the potential energy. Thank you for watching our video.